Welcome. In this video I'm going to show you how you can use binomial tables. There are actually two types of tables that I've come across. The first one is a regular one, which will show the probability of k out of n successes with a probability p of success on each trial. And cumulative ones, where it will show the probabilities of k or less out of n successes with probability p of success on each trial. I'll briefly discuss both of these and how you should use them. To some extent, the steps are the same for both tables. First, the regular version. The step is to first find the sample size n, that section, then find the k value in that section, and then find the column matching your p-value, and at the intersection you will find the probability. So let's use an example. I want to determine the probability of 4 successes in 5 trials if the probability of success on each trial would be 0.2. So this means that my sample size is 5. So the first thing I do is I look in this n column and try to find n equals 5. So that's over here. So basically I can ignore everything else except this section. Then my number of successes that I'm interested in is 4. So I look in the k column, and in my section I look for k equals 4. Then the last thing is to find that probability of success in each trial. In this example, 0.2. So let me have a look. That's all the way up here. There's 0.2. So we had this row selected, and we have this column selected. So that probability is 0.006. So we can actually have the exact same 3 steps if the table shows accumulative probabilities. So then we still find the sample size, we find the number of successes, and find the column matching your p-value. But now the problem is to find, for example, 4 successes or less. So I still have a sample size of 5. So I still look in my n column for 5, and then for k equals 4, and add the column of 0.02. So we'll add the intersection of this one and this one, which is rounded to just basically 1. So there's a very good chance that you will have, it's almost a given that you will have 4 or less successes out of 5 if the probability on success on each trial is 0.2. So be very careful when you're using tables, which table you're actually using. Is it the cumulative one or is it the regular one? For both of them, there might be a few problems that you could run across. The first one is if your probability value is greater than 0.5, but your table only has columns going up to 0.5. There's a reason for that, because we can actually translate a question into the same question, but then looking at the failures. What we mean with that is if the probability of success is greater than 0.5, then the probability of failure will be less than 0.5. So for example, the probability of 3 or less out of 10 with a probability of 0.8 would actually be exactly the same as the probability of 4 or more out of 10 failures, where the probability of a failure is 0.2. We then simply solve this last one by pretending a failure is actually a success. There's still a problem with this last one, which brings me to my second problem, which is what if we have something with or more instead of that we want to know the probability of or less? Well, in that case, you could use what I call the remove from all trick. So the total probability should be 1. So I could say that the probability of something or more plus that same something minus 1 or less should equal 1. Now I can simply do some basic math and say, well, therefore the probability of k or more is the same as 1 minus the probability of that same k minus 1 or less. And since this last one I can look up in the table, I just need to remember then that I should subtract it from 1. And that's one way to solve these two problems. A last problem that I would like to discuss is what if your p-value, the probability of success on each trial, is simply not in the table. So for example, in my table, 0.32 didn't exist. Now, it depends a bit on your lecture or whoever it is you're doing all this for. Perhaps you're doing it for yourself. You could perhaps just round it to the nearest one, but slightly better might be to use some linear interpolation or a more sophisticated version than that, but let's keep it not too complex. The steps are a little bit hard to follow, so I'm going to make a small little diagram. So the first step is to look for the two values of p that you do have in the table. So for example, in my case, there is a 0.3 for p, and I also have a 0.35. So I'm just going to sketch out a little diagram up here. So those two I do have, and my 0.32 falls somewhere in between there. So 0.32. So this might help visualize what we're about to do. So this is our situation at the moment. The probability connected, for example, with n equals 5 and k equals 2 for 0.3, I can find in the table, and in my case that gave me 0.837. It's actually for the cumulative version, so 2 or less. And this is 0.765. And the one we really would like to know now is what should be over here. So linear interpolation then actually says, well, we're just going to look at how big is this part. So that's 0.02. So 0.02. We're going to have a look at the total difference here. So this whole thing is 0.05. 0.05. So from that we can deduce that these two are, this part is actually 40% of the entire range. Now I can have a look at the bottom here and say, well, wait a minute, this part has a certain length, which in this case turns out to be 0.072, 0.072, and 40% of that would be 0.0288. So what we could do is simply subtract this from our 0.837 minus this 0.0288, which will give us the 0.808. And that is then our final answer.